Good morning, afternoon, evening, whenever you have to be watching this. Today what we're going to do is we're going to give you a review of some information that you should already know coming into Math 108. Now you may have forgotten this information, you may just need to be brushed up on this information, you may have never learned this information. So we're going to review it real quick to make sure that we can start you out this semester on the right foot. Now the first thing that we're going to review are the types of sets. There are two types of sets. We have a finite set and we have an infinite set. Okay? A finite set is a set where all the elements in the set can be listed. An infinite set is a set where every element can't be listed because there's just honestly so many of them. Okay? Now we also have what's called an empty set, and an empty set is just part of a finite set. Okay? So an empty set is just a set with nothing in it. So we can count and see that there's nothing in a set, so therefore an empty set is a finite set, if you catch what I'm saying here. So the way we write an empty set is just a circle with a line through it, okay? And that indicates that there's absolutely nothing in that set. Now that circle is not a zero, so please keep that in mind. The empty set is not the same thing as zero. The empty set is a set with nothing in it. Zero is technically something, okay? Now let's look at three distinct sets we have down here. We've got A, which is equal to 1, 3, and 5. So A is the set 1, 3, 5. Now B is the set 1, 2, 3, 4, and 5. Or B could be written as X such that X is in the natural numbers and X is less than or equal to 5. Now I'm going to help you with some of these symbols here. This vertical line here, vertical line means such that. Now this symbol here means is in, and that fancy in that you see there, that double script in, stands for the natural numbers. And we'll review the natural numbers here just a little bit. You should know what the natural numbers are coming into this course, but perhaps you may not were taught that, or you may have forgotten. Okay, so natural numbers are just your counting numbers, right? So 1, 2, 3, 4, 5, and X is less than or equal to 5, so 5 is where we stopped. Okay, C is very similar. Now, if we look at C, C is the set 5, 6, 7, comma, dot, dot, dot. And that dot, dot, dot just means we continue on forever. So 5, 6, 7, 8, 9, 10, 11, 12, on and on and on and on. Just keep going up by 1. So the way we wrote C here in a little more fancier way is X such that X is in the natural numbers and X is greater than or equal to 5, okay? Which means that we start at 5 and we go on forever listing all the natural numbers on up to infinity, okay? Now, I think we've got that. So what we'll read next is the relations between sets. So sets X and Y are equal if they contain exactly the same elements. So if they contain exactly the same elements, X is equal to Y, which we can see here. And we will just literally put an equal sign between them. Now set A is called a subset of set B if each element in A is also an element in B. So the way we'll write a subset is this fancy notation here. This just stands for subset. So A is a subset of B. If sets C and D have no common elements, they're called disjoint, which means there's nothing in common, okay? So if we look at the sets A, B, and C above, we want to ask ourselves, is A a subset of B? So I'll scroll it up here and I'll try to keep the question right there for you. So is A a subset of B? So if we look at our A up here, our A is 1, 3, 5, and our B is 1, 2, 3, 4, and 5. Now, if we recall what subset means, it means that every element in A has to be an element of B. So if we notice here, 1 is an element of B, 3 is also an element of B, and 5 is also an element of B. So is A a subset of B? Yes. Yes, it is. Because each element in A is also in B. Now, is B a subset of A? No, because B has 2 and 4 here, and 2 and 4 are not in A. So it doesn't necessarily work both directions. Sometimes it does, But honestly, if it works both directions, they're more equal. They are still subsets, but they're more equal. I hope you caught what I said there. If not, you can go back and kind of refresh on it. Now the next question we're going to ask, are B and C disjoint? Now disjoint means they have nothing in common. Now if we go up here and we look at B and C, so B and C, and I'm going to change my color here because we've been using blue a lot. So if I'm looking at B and C, and I'll look at all the elements in B, okay? So I've got 1, 2, 3, 4, and 5. Now 1's not in C, 2's not in C, 3's not in C, 4's not in C, but we do have a 5 in C. So we've got something in common. If we've got something in common, they cannot be disjoint. So are B and C disjoint? Uh-oh. No. Why? They have a 5 in common. Okay. Disjoint. Disjoint means they can't have anything in common. So even if they've got the one little thing in common, they're not disjoint. Now I told you we were going to review some of these natural number or common sets here. So that's what we're going to do here. The first one is the natural numbers, which we've already touched on a little bit. Natural numbers start with 1 and they go up by 1 forever and ever and ever. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You kind of get the point. Now the next step up from natural numbers are integers. Integers are all whole numbers, but it also includes 0 and the negatives. Okay, so you've got negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, going all the way down as far as you can go. You got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, on up as far as you can go. Okay, now one you should also know are rational numbers. Rational numbers can be written as P over Q, where P and Q are integers, and Q, most importantly, is not equal to 0. Okay, so what we like to think are terminating or repeating decimals, basically anything that you could rewrite as a fraction. Okay, now if we look at irrational numbers here, irrational numbers cannot be written as terminating or repeating decimals. Examples I have here are the square root of 2 or pi. If you know anything about pi, you're still writing digits to pi, right? Pi goes on forever, nothing, it doesn't terminate, it doesn't repeat. So these are irrational numbers. If you take the square root of 2, it doesn't terminate, it doesn't repeat, you can't rewrite it as a fraction, you can't rewrite either of these as a fraction. Okay. If you can rewrite it as a fraction, it's a rational number. If you cannot rewrite it as a fraction, it's an irrational number. Alright, so now let's look at some inequalities and interval notation setups. Now you should know how to do this coming into this course, but I do know from past experience that students in this course sometimes struggle with interval notation, okay, and comparing inequalities and interval notation. Now this first one says x is greater than 8. Now if I'm going to write that in interval notation, then what I'm going to do is if x is greater than 8, kind of thinking about it number line wise. So I'm just going to start, say, with 5 here, 6 here, 7 here, 8 here, 9 here, 10 here. Alright, so if x is greater than 8, that means I would put an open circle on 8, and I'd need to go greater than, which is to the right, if that makes sense. Okay, which means that what I can do here is I'm basically starting at 8 without really starting at 8. I'm starting around 8 and going up, okay, to positive infinity, because positive infinity sits on the right hand side of your axis and negative infinity sits on the left. Okay, so when we convert this to interval notation, if it's not equal to the point, what we're going to use is a parentheses. Okay, so that's why we write parentheses 8 on up to, you can see the arrow going up to infinity. Now, if it happened to be equal to 8, as it is here in the second one, change my color. So in the second one, it's equal to 8. So if it was equal to 8, I would color it in with a solid dot, and then I would go right. Okay, and the way we represent that is with a bracket. Okay, and that's why we have a bracket right here, then an 8. It lets us know that that 8 is included, and then we go up to infinity. I hope that makes sense to you all. Okay, now sometimes it's bounded between two numbers and it doesn't go to infinity on either side. So here we've got 4 is less than or equal to x is less than or equal to 12, which means we start with 4 and it is equal to, so we use a bracket, and it goes up to 12 and it's equal to 12, so we use another bracket to close it off on that side. Now if it doesn't have equal to signs on it, like this fourth example, 3 is less than x is less than 6, we use parentheses, we use parentheses here, so parentheses 3, comma, 6, and another parentheses, and it indicates that it lies between those two numbers, but it isn't equal to those numbers on the sides. Okay. Now the next thing you'll see in this class, we work with polynomials a lot. Okay, so you need to know some facts about polynomials before you can work with them. So the polynomial we have here is 5x squared minus 8x plus 2x to the 4th minus 3. Now, the first question is going to ask, what is the constant term? The constant term is the term without the x. So the only term we have up here without an x is this negative 3, and we do have to include the sign in front of it. That's very important. So our constant term here is negative 3. If it's positive, you don't have to put the positive because it's indicated as positive by not having a negative in front of it. If you put the positive, that's fine as well. Now the leading coefficient, this one's a little tricky here, because if we look at this polynomial, it's not written in your standard mathematical form, which we'll get to in this fourth part down here. Okay, that standard mathematical form can be important. Now, the leading coefficient always lies on the x here with the highest degree, okay, which is also your third question. So the leading coefficient is the number out in front of that x here. So the number out in front of that x with the highest degree. That's your leading coefficient. It's not necessarily the one that comes first, because I can rewrite this where negative 3 comes first. I can rewrite this where negative 8 comes first. Rewrite it where 2 comes first. Rewrite it where 5 comes first. You can switch it all around, okay? So the leading coefficient in your polynomial is always the term here out in front of the x with the highest exponent, okay? Now, if you happen to use an r, an s, or y as your variable, you're just going with the variable with the highest exponent. So our leading degree here is 2. I'm sorry, I said that wrong. Our leading coefficient is 2. Our leading degree, or our degree here, let me change colors once again. Our degree here is like we highlighted here. The degree is the highest exponent on your variable. So our degree here is a 4. So our leading coefficient here is a 2 because it is the number out in front of your highest degree. And your degree, your highest degree here is 4. Okay. Now, this last question follows up and it says, well, how would you write the equation in standard mathematical form? Well, what we would do is we'd put the highest degree first, the second highest degree second, and kind of work our way down. So it would go like this. It would go 2x to the 4th plus 5x squared minus 8x minus 3. And you see we kind of started with the highest exponent here, and we worked our way down to the lowest exponent, which in our case was actually no exponent. So our highest one was 4, our next highest one was 2, and then this one didn't have an exponent, but it was imagined to be 1, right? There's an imaginary 1 sitting right there, not, you know, kind of hiding right there. This understood to be 1. And then this one had an exponent of 0, because there was no x to even have an exponent on. Okay, so kind of worked our way down. All right. So, now that we kind of know some basic information about polynomials, the next thing that we're going to do is we're going to simplify polynomials, okay? So it says simplify the following. 5sx minus 2y plus 7z to the third in parentheses plus another set of parentheses which include 2y plus 5sx minus 4z to the third. Okay. Now what is key here is they're added. And that means that addition is given to each one of these terms here. So nothing really changes. Okay. So what happens is I need to combine like terms. So the like terms that I have here, and I'll try to use a different color for each of them. So 5sx and 5sx are like terms. Okay. So what I can do, 5sx and 5sx add to be 10sx. Now my next terms that are in common are my negative 2y and my positive 2y. Now negative 2y plus positive 2y is going to give me a 0, right? So negative 2y and 2y cancel each other out. So I don't even really have to write that in the next section because this cancels this out. Because this one's negative and this one is positive. Now lastly, I have a 7z to the third plus a negative 4z to the third. So 7z to the third minus 4z to the third, which should give me plus 3z to the third, which is what is left over. So my final simplification here is 10sx plus 3z to the third. Now I can't combine these last two terms because their variables aren't the same. Their variables have to match in order to combine them. This one has a variable of sx. This one has a variable of z to the third. Therefore, they cannot be combined. And that is as simple as you can go. All right. So the next thing we'll look at is the distributive property. Now, the way the distributive property works is we have A times B plus C. And essentially what I'm doing is I'm distributing this A to the B, and I'm also distributing this A to the C. Okay. So I've got an example here. It says simplify the following using the distributive property. We've got x times 3x plus y. I'm going to distribute this x to the 3x. I'm going to distribute this x to the y. And what I'll get is x times 3x is 3x squared. And x times y is just xy. And I have distributed out that x. Now a more complicated method of the distributive method is the full method, where you have a plus b times c plus d. And essentially what you have to do here is you have to distribute your a to your c and to your d. And then you have to come back around and you have to distribute your b to your c and distribute your b to your d as well. So what you get here is you get AC when you distribute the A to the C. You get AD when you distribute the A to the D. You get BC when you distribute the B to the C. And you get BD when you distribute the B to the D. And you have to add all those together. Pretty simple. We'll work with the full method some more this semester, especially when we come around to foiling and factoring. Okay. Next up, we are going to divide monomials. Okay. So we've got 3x squared minus 4x all divided by x. Now, just to kind of help you visualize how this works, we need to distribute this entire bottom term, which is just an x here, to both top terms. Okay. So the way I'll rewrite it, just so maybe you could see it a little bit better, is 3x squared over x minus 4x over x. Okay, their common denominator here is the x, right? So what happens here is this x cancels out one of these x's. So that 2 goes down to a 1, right? And this x is now gone. So I'm left with a 3x here. And this x cancels out this x because they're both the same, right? X over x is just 1. So that leaves us with a minus 4. 3 over 3 is just 1. 4 over 4 is just 1. 10 over 10 over is just 1. Anything over itself is just 1, so it just cancels itself out, and we're just left with this forward here, right? Simple. Now, it only works when your x is in the denominator, right? You can't, if this whole thing would have been flipped and the x would have been in the numerator and the 3x squared minus 4x would have been in the denominator, it would have been a whole other scenario, and we wouldn't have combined in the same method, okay? So be careful of that. Change back to my blue marker, scroll down to page 4. Now, I think this is the last thing we review in the review. It is. It's the coordinate system. Now, the coordinate system is very important. We graph a lot this semester. We use your TI-84 to graph a lot this semester. Okay. Now, the coordinate system is made up of 4 quadrants. We've got quadrant 1, which is in the right-hand side. Quadrant 2, which is in the top left-hand side. Quadrant 3, which is in the bottom left-hand side. And quadrant 4, which is in the bottom right-hand side. Now, your x-axis is your horizontal axis, right? There's your x-axis. It goes along here. Your y-axis goes vertically. So you can see your y-axis here, so it's the line that's indicated here, right? So we got our vertical line there. Our origin is our point in the middle. So our origin is that 0, 0 point in the middle. And if we're going to graph a point, say 2, 3, the way it works, let me bring out the red, is we started our origin here, and we count 2 to the right, 1, 2, and then we go up 3, 1, 2, 3, and our final point is graphed right there. That is the point 2, 3. Pretty simple. Hopefully you've seen the coordinate system before. And that completes your review. Hopefully you are ready to start that real course material of Math 108. If you have any trouble at all with this, please don't hesitate to reach out to me. We can see what we can do about this and make sure that you're in the correct course if you're really struggling with it that bad. Maybe you placed into the wrong course or added the wrong class. Other than that, please continue on to chapter 1.1, and I will see you there for that lecture. Thank y'all, and have a good day.